This is Lab 5, Choose Your Own Adventure for Physics 22. The purpose of this experiment is to compare the predicted and observed motion of a ring from the FRC 2024 season, Crescendo, being shot into the goal. In this lab, I will analyze a video of a ring being shot into a goal, translating rotational energy to translational energy. I will determine the final speed of the flywheels after the ring is shot. The fundamental physical principles here is the conservation of angular momentum. So L final equals L initial. And then the equation for L angular momentum is mvr, mass times velocity times the radius of the object. In the experiment, some initial conditions be the mass of the ring, which is 0.235 kg, and the mass of the flywheels, which combined are 0.435 kg. And I looked this up. The ring is the note from the Crescendo season, and the flywheels are 6 Coulson wheels, and I just modeled it as one long cylindrical object. The system and surroundings are, the system is the ring, the robot, and the earth. And the surroundings are the speaker, the people, and everything else, basically. This was my experiment. We did repeated trials of this, but I only analyzed one's motion. This is my model. I modeled the note as a ring and the wheels as a cylinder, and I input the radius, calculated the inertia and the velocity. The note actually does have some initial velocity, but I just modeled it as if it was standing still. And then I put in the wheels, the radius and inertia, and I modeled the velocity from the speed of the motor that was driving it, which was a WCP Kraken. Then I used conservation of angular momentum to find the wheel velocity final using note velocity final from my experimental data. Some sources of error could be human error in model code, friction with wheels that not accounted for, energy loss due to heat not accounted for, and I had to adjust the axes due to the filming angle, so my adjustment could have been incorrect, and my axes were messed up, which would lead to different velocities in the experiment than in real life. Discuss how my results would change if I used wheels with a bigger or smaller radius. If I used wheels with a bigger radius, my inertia would be larger, which would lead to more energy in the system. And then if I used wheels with a smaller radius, my inertia would be smaller, even at the same velocity. What does it mean? Is the collision elastic or inelastic? Since this is real life, the collision is inelastic because some energy is always lost due to heat. And in fact, when we were doing the experiment, we could feel the wheels get hot and the motor get hot, leading us to conclude that this collision was inelastic. I analyzed a video of a robot shooting a ring into a goal. I used conservation of angular momentum to determine the final speed of the flywheels after the collision. And then I used Tracker to obtain experimental data and modeled the math of the collision in GlowScript.